Hello everyone, today in this video we will be discussing on the topic Turing machine. Okay, so module 4 is all about some problems on Turing machine and some theoretical concepts. Fine, so let's get started with the basic definition of what is Turing machine. There are like 8 to 10 problems which are standard problems and which are asked in exam. Okay, means from those 8 and 10 questions only they will be asking every time. Okay, so we'll be discussing each of those questions in this video. Okay, so Turing machine is nothing but we'll be having a string. We'll be seeing if the string is valid or not. Suppose that I want to accept a string AABB. Okay, so what is the working of Turing machine is that if I have to accept AA and BB, I have to see there are equal number of A's and B's. In the starting A I have and in the ending I have B's. Okay, so how will I verify that? So in Turing machine what happens is, firstly you will be starting from A and you will be checking if there is an equivalent B for it or not. If you find a B, you will be marking it as valid, means this pair is valid. For this A there is a B here. Then again you will come back and see which is the next A. This is the next A. So what you will do, for this A you will be finding the next B. You will go here, this is already done. Then you will go here, this is the next B. This pair is also done, you will mark it as done. And after that again you will come back and see if there are any more A. There are no more A's. So what you will do, you will move front and you will come here, this is the blank space. So why blank space is that? Because we want to know when the string has ended. That is denoted by capital B. Okay. So this is how the Turing machine works. So there are some steps to construct the transition diagram and write the ID. Okay, ID means instantaneous descriptor. So let's consider the first question of this module, which is the question to construct a Turing machine for the given language. Okay, so this is the question which we have. L is equal to a power n, b power n, where n is greater than or equal to 1. Now you tell me what are the possible strings which we can form from this given language. N is greater than or equal to 1. Pay attention to this one, because if it is greater than or equal to 0, the transition diagram will be different. Okay, so here we have n is greater than or equal to 1. So what is the least string which we can have when n is 1, right? If you have n is equal to 1, we will have AB. If you have n is equal to 2, it will be AABB. If n is equal to 3, we will have 3A's and 3B's and so on. So let's consider the string which is triple A and triple B. Why? Because we want to allocate all the possible combinations. Okay, means if we take AB only, it will be just valid for AB and it might not be valid for AABB. So we are just taking a bigger string so that it will be covering all the possible cases. Okay, so what is your first step? Whichever string you have, what you have to do, you have to write here. You are considering AAA, BBB, so write here like that, and after that at the end you add capital B, and you have to make a tape like this and make some partitions here after each letter. Okay, so this is your string here. Now you have to start from here. Okay, your first step is like whenever you encounter an A, what you have to do is you have to remove A and mark as X. I'll write here, A will be marked as X and B will be marked as Y. Okay, so let me give you an overview of how we will be approaching this question, and after that I will be telling you how to draw the transition diagram. First you are starting from here. You have encountered an A here. What is your first step? Firstly you have to make it as X. So I will be cutting this one and marking it as X. Then I will move to the next one. See, I have done for A, right? What is my next step is I want an equivalent B for it. So I'll be skipping this A, I'll be keeping it as such, and I'll be moving here. A is encountered again, I'll be keeping it as same only, and I'll be moving to the next one. Whenever I encounter the first B, what I will do, I'll put as Y. After I have encountered B and put as Y, again I have to move back. Why I am moving back? Because I want to see if there are any more A's so that I can find a pair for B also. fine. Then I will move back and see, this is the first A, no, this is the first A, yes. So what I will do, I will mark it as X. Don't worry about how will I know if it is first A or not, how will the machine know if there are any more A's, that we will be discussing more in the transition diagram. Okay, for now just get the logic of it. I will mark it as X here, then again I will find B, I'll keep it I'll keep A as such, then I'll move here, Y I have to ignore because I want B, I'll come here, I'll get B, I'll mark it as Y, again I'll move back, I want A, I'll move here, this is the first A, I'll mark it as X, then again I'll move here, Y, Y, whenever I get B, I'll mark it as Y, again I will move back and see if there are any more A's left, it's not, any more A is not left, so what I will do, again I will move here till here, I'll reach capital B. Capital B marks the end of the string, fine. So this string is valid. If I am able to reach the blank space, that means the string is valid, else it's not valid. Alright, so this is the way we approach this question. Now let's see how to make the transition diagram for it. For that I have to make this tape here. Now we'll consider one by one, one step at a time. A, B, B, B and capital B. Now let's see how to approach this means how to make the transition diagram for it. So your first state will always be Q naught. Make here Q naught, this is your first state. Where are you starting from? You are starting from A, right? So whenever you encounter A, what I had told you to do, I had told you to put X there, right? So what you will do here, whenever you encounter A, you will mark it as X. If what you are encountering, you will write that first. Okay, what you are encountering first, A, write A here. Whenever you encounter A, what you have to do, you have to mark it as X. Then what you will do, you will move right, right? See, after this one what we had done, we had moved here, this is which direction, right direction, right? So we'll move here right. These three things you have to remember. For each of these transitions you have to do the same thing. Whenever you encounter A, mark it as X and move where, right. Okay, then we'll move to the next state, Q1. In Q1 what we have to do, whenever we encounter A, we don't want to do anything, right. See, this is done already, I have put as X here, so let's make it here, X I have done. Next I have moved right. At this position I have encountered what, I have encountered A only, right. I have encountered A. What I have to do, I have to not do anything, that means I will rewrite A on it again, right. See what I had done here, whenever I encounter A in the first position, I rewrote it as X here, means I overwrote as X here and move to the next state. Now since I got A here, I don't want to do anything, I want it to remain as A, I will again write A on it. So what I will do, A, whenever I encounter A in the second iteration, I will rewrite A on it and I will move to the right position. How much times I have to do this one? Until I encounter first B. So whenever I move to the right, again if I find A, I have to stay in the same state and move till I find B. So this will be the self loop. Okay. First encounter X, I will move to this state and I will skip all A's, I will rewrite A on it and I will move to the right, and after that whenever I encounter the first B, I have to move to the next state. So whenever I encounter B, what I have to write, Y, and where I have to move, I have to not move right, I have to move left, because I have found B, then again I will check if there is A or not, right. For that I have to move where, I have to move left side. So after encountering of Y, after encountering of B, I will rewrite B as Y and I will move left. Whenever I move left, I will encounter A here, but is this the first A? How will I know that? Let's see how to know that if it's the first A or not. What I will do, I will just move again to the left. Okay, means if I encounter A, I will not do anything, I will move to the I will keep on moving to the left, I will rewrite A on it and move to the left. Again I will move to the left, again I will move to the left. Whenever I move to the left and I found X, what does that mean? From this position I moved left and I found X, that means this is the next A to be considered, right. So how will we depict it using this transition diagram? So suppose that from Y I moved here A, again A I rewrote A on it and I moved left, again I rewrote A on it, again I moved left. Now what I am encountering? I am encountering X, right. So whenever I encounter X, what I have to do, I have to not do anything, I have to write x on it again. So I'll write x on it again, and I want a, means I have to come to this position to do the operation. So I'll move to the right. Okay, that's what we are doing. Whenever we encounter x, we'll move to the next position a, so that we know for sure that this is the a which is to be considered now. All right, so this is the state which is the same state as this one. So I'll move here again. Why this one? I'll tell you. Wait, x, x and r. From this position again I came here, because observe here, I am doing the same operation again as I did for this one. I encountered a, I skipped the rest of the a's, find b, again I came back here. I have to do the same thing again, isn't it? I have to find again b for it, and again whenever I find b, again I have to come back. So instead of making a new state and again writing the same things, I can move to the same state here. All right, so whenever I move here, then again the same thing which will happen. Let's see what is the difference which we have to make here. I'll encounter a here, then again I'll mark it as x here, then I will move to this state, and in this state whenever I encounter a, I have to ignore it, I'll move to the next state, and we have not defined anything for y. Whenever I encounter y, that also I have to ignore. I'll rewrite y on it. Whenever I encounter y, rewrite y on it and move to the right position. Whenever I move to the right position, if I find b, what I have to do, I have to mark it as y and move to the left. Mark it as y and move to the left. I'll move to this state now. Left also I encounter y. What I have to do? Nothing. Just ignore it and move to the previous state. So here also if I encounter y, write it, rewrite y on it and move to the left. Okay. Whenever you move to the left, you might find a or y. If you find a or y, do the same thing. Rewrite the same letter on it and move to the left. Whenever you find x, that means the next a is the a which is to be considered. So I'll move back to here. Next a also I'll consider, mark it as x here and move to the next one. Here I find y, ignore it, y, ignore it, and again whenever I find b here, I'll write it as y and move to the next state. In this state I am present here, and if I find y here, what I have to do, I have to move to the left, again left. Whenever I find x here, what I have to do, I have to come to this state, x, x, r, means rewrite x on it and move to the right position. Here I will find y, means I am in this position and no more a is left, that's why I find y here. What does that mean? If I find after x, if I find y, that means the string is over here. If the string is over, I have to move to the final state. How will I move? I just have y left here. So what I will do, from this state I will make a transition for y, r, until I find b. So I'll make a self loop here, where I will find, whenever I find y, I have to just ignore it and move to the last position. Last position means if I encounter b here, I'll rewrite b on it and move to the right position. Okay. If I encounter b, I'll just write b on it and move to the right position. That means like this. I'll move to the right position and that's the final state. Okay, this is known as halt state. So that's what I explained here. If I find y here, what will happen? I'll come to this state here, q3, and whenever I find how many y's here, what I will do, I'll just self loop it, and whenever I find b, what I will do, I'll just write b on it and move to the right, and then I'll reach the halt state. Okay, so this is how you'll make the transition diagram for this question, and after that you have to make the instantaneous descriptor. Okay, how to write that is, we'll be looking at this diagram and writing the instantaneous descriptor. So for that, let's consider a sample case here. So let me consider here as, firstly you will be writing like this. Okay, here you will write q naught a b b b, which is a string we are considering a b b b. Okay, so this is the string which you will be considering. So after writing this, which is start state, you have to write first here, and what you have to see is q naught on a, q naught on a, where you are going. Q naught on a, it will be made as x, and I am moving to the right. So two steps you have to do. Firstly I will write two steps, then I will directly do. Okay, so see here, q naught is transferring a as x, so you will write it as q naught x a b b b. Q naught is made as x, means a is made as x by q naught, and which state I am going? From q0 to q1. Also I am moving to the right. So q0 to q1, first write it as q1. Q0 is getting shifted to q1, and this x is same, b. Then I am moving to the right. So for that, what I have to do? I have to move this to the right position. So I'll write x here and then q1. So these three steps I will be doing for the next instantaneous descriptor steps. What I will do? I'll just write it directly. Means q0 on a, what I will write? q0 on a means x, and right means I'll write it after x, and which state it went? q1. So I'll write x and q1. Okay. For the next steps, I'll do the same thing. q1 on a. q1 on a means again a r. That's nothing. You'll just write here x, a, q1, b. Okay, because I have moved to the right and it is a only, I will not make any change, and the state is q1 only. Then again I have to do q1 on b. If I encounter b, what I am doing? b1 b on y. So first let me write this step also. It is x a, and here I have q1, and it is made as y. Okay, y and b. Then here x a, q1 is made as y, but it is moved to left, right? So what I will do? I'll move this to the left. So firstly I'll have q1 here and a after that, and y b, and q1 is shifted to q2. So I'll write here x q2 a y b. Okay. So this is how we do the transition, and then I'll see q2 on a. q2 on a is again same thing, aal. So I'll just write here q2 x a y b. Then q2 on x. What is q2 on x? q2 on x. q2 on x is the same thing, x only. q2 will become q0 and it will move to the right. So I'll write, just write here x q0 a y b. What is q0 on a? q0 on a is this one, x q1 y b. q1 on y is y only, and it will move to the right. So x y q1 b. If it encounters b, I have to move to the new state q2, right? So if I move to the new state q2, firstly I have to make the change here, and it is moving to the left. Okay, that also I have to consider. So firstly I'll write x q2 y, and this also turn to y, and then b. Okay, and after that q2 on y move to the left, x q2 x y b, and after this one q2 on x. q2 on x is again this one, write x on it and move to the q0. So x q0 y b. q0 on y. What is q0 on y? q0 on y is this one. Move to the right and rewrite y on it. So what I will do? I'll move to q3. This is q3 state. So x y q3 y b. After that, what is q3 on y? It is same state only, and move to the right. q3 b. What is q3 on b? It's the final state. I'll write b on it and move to q4. So I'll move to q4 first. I'll move to q4 and it is right. So I'll write here b, and I'll write here q4, and this is the final state which I have reached. Okay, so this is the instantaneous descriptor. Okay, as I had told you before that you have to pay a lot of attention on what they have asked. The question was here, n is greater than or equal to 1. What if the question was like this, a power n b power n is greater than or equal to 0? At that case, what is the string which is to be accepted? Epsilon also can be accepted. That means I can directly reach the final state from the starting state. How will I depict that in this one? Here, if I want to reach the final state directly, I can't reach. Why? Because I don't have anything. Epsilon means empty string. Okay, so here I'll just have b here, blank space. So if I just have a blank space, I have to reach to the whole state. So the changes which I'll make here is just that if it is not an empty string, at that time I have to have a transition for y also. So I'll make a self loop of y here. I'll make it here. The rest of the things are same here. I'll have q0 AXR, and from Q1 what we have AAR. If it's A will be ignoring, if it's Y also will be moving to the next one. If it's B we will mark it as Y and move to the left. From Q2 A and L will be there, AAL and YYL. If it is X we'll move to the starting state XXR, and from here you have to make the change. Here if you have nothing left here, then you have to directly reach the whole state, right? BBR. From blank space, if you encounter blank space, write it again blank space and reach to the final state. So Q3 will be the final state here. This is the whole state. And if you have if you don't have empty string, that means it should also accept AB also, right? At that case what will be the final string? X, Y and B will be here. So Y also transition should be there. It can be either Y or it can be multiple Y's. That also I have to include here. I'll reach here after, if the X is over, at that time I have a line of Y that also should be processed. So for that I'll have a loop here, Y, Y and R. Okay, so this will handle the Y cases here, and after that it gets over, it will reach to the final state. This for the question where you have n is greater than or equal to 0. Okay, so the only difference is that here will not have this case direct reaching to the final state in the previous one, but for the Y what we had what we had is we'll reach to this state, and here we'll have all the process for Y, and then reach the final state. Okay. The next question is to construct a Turing machine for the language A power n, B power n and C power n. Okay, and n is given as n is greater than or equal to 1. Okay, so how will this string be? If I take n as 2, at that time the string will be AA, BB, CC, right? So what we can do is we can substitute A as X and B as Y and C as Z. So what will be our approach is that whenever we find A here, what we will do, we will mark it as X. My next aim will be to find out B. Whenever I find B, I will mark it as Y. My next aim will be to find C. Wherever I find C, I will mark it as Z and then turn left. Y left, again I have to find A, B and again C for that. Okay. So I'll come here and ignore these things, and when I encounter A, I will mark it as X. Next I have to search B, I'll mark it as Y. Then I'll search C, I'll mark it as Z. Then I'll see if there is no more A and B. If there is no more A and B, I'll come front here. That will be the backspace here, and sorry, blank will be here. So whenever I encounter blank, that means the string has ended. So this will be our approach. So how we'll be doing that is, firstly let's take the tape here, AA, BB, CC and capital B. So let's try to construct the transition diagram. Okay, so what is our first state? Our first state will always be Q0. Whenever we encounter A, what I have to do? I have to mark it as X and move right. Then I will be in Q1. How many A's I encounter, I have to just ignore it and move to the right. Whenever I encounter B, I will move to the next state, B, Y and R. This is Q2, and in Q2 what I have to ignore n number of B's, so BBR. After that, whenever I encounter C, what I have to do, I have to move to Q3. Q3 is my new state. Here I have to encounter, I'll reach Q3 if I encounter C, I'll mark it as Z and move left. Whenever I move left, suppose that C here, this is X. Then here I have written as Y. Then I got here as Z. And when I am moving back, I am encountering B, I have to ignore it. So what I will do is self loop here, BBL. Also I encounter Y here, so YYL. Also encounter A here, AAL. And after that, if I encounter X here, at that time I have to move to again this one, because that marks the start of the new string. So I'll move here on XXR. I'll just rewrite X on X and move to the right. So I am at this position now. Again I will mark it as X and I will move to the next position. In the next position we have Y here. So what we have to do, we have to just ignore it and move to the next state. Okay, so I will be writing here Y, Y and R and moving to the next state. Here I have B, so I will move to this state, and here I have to ignore n number of B's. So I will be ignoring them, and but before that I will mark it as Y. and move to this one. Here I have to ignore z also because I want c, right? So z also I have to write here z z r. I'll ignore the how many z's are here, then I'll move to c. Whenever I encounter z, whenever I encounter c, I'll mark it as z and move to the left. Okay, and from here again when I come back I am encountering z, so I have to write here for z also. I'll be writing here z z l. So I'll ignore n number of z's, n number of y's, and then whenever I encounter x, what I will do, I'll move to the right. So here after x, if there is no more a's, what I'll reach is I'll reach y. So if after this point if I reach y, that means the string has ended. So I have to mark here for y. So I'll make here as yyr. I'll move to this state which is q4, and here I'll ignore the n number of y's, followed by after the y's are ignored, then I'll move to z also. So I'll move zzr, and here also many z's are there, that will be ignored here by the self loop, and after that I'll finally reach the b. So I'll write here as b bbr. Okay, so this is the final state, and here the machine will halt. Okay, here just the thing, n number of z's will be ignored. After that we'll reach b. B will be overwritten by b, and after that I'll move to right, and that's the final state here. So this is how we make the transition diagram. Let's consider example for the instantaneous descriptor. So let's take the string, the same string AA, BB, and CC. So by looking at this, we'll be writing the instantaneous descriptor. So let's take here Q0, AA, BB, CC, and capital B. So I'll be skipping a lot of part because if I do for each of the steps, it will take a long it will more number of iterations. So I'll be just writing the important steps here. See, what is Q0 on A? Q0 on A is x and move to right Q1. So I'll mark it as x. I'll move to the right with Q1, BB, CC, and B. A will be ignored. I'll remain in Q1. Then what I'll encounter is B. So B will be replaced by Y. So I'll be writing here x, A, Y. Then here it is Q2, and here it is B, CC, B. This B will be ignored. For this one, it will be Q3, and it will be marked as Z. So it will be like this: x, A, Y, and this B will be as such, and here I have Q2, CC, B. What is Q2 on C? It is Z, and move to the left. So it will be Q3, X, A, Y, Q3, B, and here it is Z, C, B. Fine. And after that, what is Q3 on B? Q3 on B, it is the same thing. Keep it as such and move to the left. I'll move to left till I reach X. So I'll reach here Q3X, A, Y, B, Z, C, B. Q3 on X, I'll move to Q0, X, Q0, A, Y, B, Z, C, B. Here Q0 on A, again it will become X, 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 Q1, Y, B, Z, C, B. And again the same things will happen until I reach this state, X, X, Y, this Y, and when I encounter here, it will be again become Y, and here it will be Z, and I will encounter the second C, it will become Z here, and here is the B. So when I encounter this one, I'll move to this states. I'll move from Z to Y, then again X. I'll check if it's no more there, means the A is not there anymore. So I'll move again here. This will be this loop will happen here. After that, the Z loop will happen here, and after that, when I reach here, it will be like this: X, X, Y, Y, Z, Z. After that, I'll be in Q5, B, Q5 on B. I'll reach to the final state QF. Okay, and it's right. So what I'll write is B here and QF here. Okay. So this is all for the second question, which is A power n, B power n, and C power n. Coming to the third question of the Turing machine, what we have to do is we have to define means we have to make a transition diagram for the even palindrome. Okay, so what do I mean by even palindrome? Just that it's a palindrome with the length even. Okay, means even number of characters in it. For example, if I take here ABB, BBA, okay, this is an even palindrome. ABAB and BABA, okay, this is an even palindrome. So how do we approach this question here? So for this what you have to do is we'll be starting from here, and suppose that this is the string. What we will do is whenever we encounter an A or B at the starting position, if I encounter A, I should have the same character at the end also, right? That's what a palindrome is, right? We can divide into two parts, and the first character is the last character, second character is the second last, and third character is the third last character. So how do we know that if A is starting, how do we confirm that A is at the ending also? One thing is there, the character before the blank space is the last character. So what I will do, if I encounter A first, I will be in search of A. I'll be searching the A or B at this position. Okay, at this position I will be searching if it's A or B. How will I know this position? This is behind the blank space. Okay, so what will I do is, first whenever I encounter a letter here, I'll make it as blank space. Why I'm making it as blank space, I'll let you know. Okay, after making it as blank space, I've encountered A, right? What I will do, I'll search for blank space. I encounter here blank space, so I come back here and see if it's the same letter or not. If I have encountered A here and I get A here, that means I have reached the got the same letter, so I'll make it as blank space. Then what I will do, I'll again come back and search for blank space. Why? Because I have to start from the next character. The next character comes after the blank space. So I've encountered B here, so I'll make it as blank space, and then again I'll search here for the blank space. Whenever I encounter blank space, behind that character is the last character. So for this character, I'll get this B and make it as blank space. Again I'll come back and see B is here, make it as blank space. Again I will come back here, behind the blank space is the last character, I'll make it as blank space. When all the strings are over, means all the characters are over and I have got here blank space, that means it's a even palindrome. Okay, that's how we approach this question. So let's consider this example and make the string here. Okay, let's take AB and BA. Okay, so this is the string which we will be considering and making the transition diagram. Okay, so which is your starting state? Always your starting state will be Q0. Okay, what is the first letter? It's A. Whenever you get A, what you have to do? You have to make it as a blank space and move to the right character, and then you will encounter n number of A's and B's which you have to ignore. Means if it's A, write A on it and move right. If it's B, write B on it and move right. Fine. And whenever I encounter B at the last, means blank space at the last, that means I have to move to the left. Okay, so if I encounter blank space, I'll write B on top of it and I'll move to the left. Now I'm at this position. At this position I'll check if it's A or not, because I've got A here, right? So I should get again A here. Only if it is A, I'll be accepting it, else I'll not be accepting. So if it's A, then I'll make it as blank space and move to the left. Okay, because I have got A here, behind the blank space I should get again A. So this will confirm the even palindrome, means palindrome. Okay, and when I get A here and move to the back after making this as blank space, this is already blank space here because of the first iteration, and when I move back here, I'll be in search for blank space. Until then I'll ignore all A's and B's. So in this state Q3, if I encounter A, keep it as A. If I encounter B, keep it as B. Fine. And after that, whenever I reach a blank space here, I should come back to the same position, which is this position. Okay, I encounter a blank space here and come back here. Means whenever I encounter here B, at that time I should write B on top of it and move to the right. So I'll be checking for the next character. So this will repeat again. From here again it will go like this and come back. But this is only defined for A. What if I get B? Like here, if I get B, again I'll be doing the same thing, just that instead of A I'll be writing B here, and finally I'll be checking for B here also. Means I encountered B here, so the last character should also be B. So I'll make this as blank space. I'll make it here. For B, I'll make it as blank space and move right, and in this state I'll make I'll get n number of A's and B's which I'll be ignoring, AAR, BBR, After that I'll be getting a blank space here. I mean here I'll get a blank space, so I'll move to the left and I'll be checking if I get B or not. If I get B only, then I have to consider it. Okay, so if I get here B, make it as blank space and move left, then again ignore n number of A's and B's and again move here. So once what happens after some time, if it's an even palindrome, at that time all the B's and A's will be turned to blank spaces. So at a point of time I'll reach here and I'll be in this state. So there are no more A's and B's left here, so the string is over. What I have to do is I have to I've got all the blank spaces, so I have to define something for blank space here. So what I will do, I'll just make it a final state here. If I get a blank space, move to the right, and that is the final state. We need not reach this blank space because all the blank spaces are equal, so we can at any blank space we can halt the machine. So I am sure if I get two blank spaces together, means in the mid of the palindrome, that means the palindrome is over, right? So I can halt the machine from that state. Okay, so this is the transition diagram. Let's see how to do the instantaneous descriptor. What do we do for writing the instantaneous descriptor? Keeping this transition diagram here, what you have to do first, we'll be writing here the string which we are comparing. Suppose that the string is AB BA. Let's keep it a small string. Okay, so what is Q naught on A? Q naught on A is a blank space and move to right. So what I will do, which state I am moving, Q1, and making A as blank space, Q1 B B A. Then I have to just ignore all of this. Here also B is there, and I will be just ignoring these B's here, and I will reach the blank space here. So I am just keeping that part because if I write it will become a long instantaneous descriptor. So I will be writing here Q1, and if I encounter B, what I have to do, I have to move left and Q2. So when I move left from here and go on Q2, what will be my instantaneous descriptor is BB, and if I move left here, so what I have to make here is I have to just write it as blank space and I have to move left. So I will be in Q2 and I will have the A here shifted because when I shift Q1 here, it will be Q2 here and AB will be here. So then I have to see for Q2 on A. What is Q2 on A? It is I have to put a blank space and move to left. So I will be moving Q2 here, so it will be BB, and Q2 will become Q3. So I'll have Q3 here, B, and this is turned to blank space. So blank space and blank space. Again I will come back here ignoring n number of A's and B's. So finally I will reach here Q3 B, and here it will be BB and BB. After this Q3 on B, I will from Q3 on B I will reach back to Q0. So after that I will encounter the blank space here. So when I encounter the blank space, then what I have to do from here, no, before that I guess I'll not reach there. See, Q3 is there, Q3 on B. What is Q3 on B? Q3 on B is in the same state, so I'll reach here Q3 on, let's write that state here. So it will be first. So what actually happens is at this point what is Q3 on B is there, so I'll move left, so it will be B, then here I'll have Q3 and BB and capital B capital B. At this point again I will move back and I will reach this state here. Here what I'll have is Q3 and capital B, BB and BB. This is the right state here, but when I have Q3 on B, what I have to do, Q3 on B means I'll write B on top of it and move to the right. So that means I have to write B on top of it and move to the right with the state Q0. Then I'll have Q0 BB and two capital B's. After that Q0 on B, what is Q0 on B? I'll reach to Q4. Okay, after writing the blank space here, so I'll reach to Q4 B and B, Q4 small b, capital B capital B. After that when I reach this state here, if I encounter a number of A's and B's, what I have to do, I have to ignore it and move to the next state. So I'll ignore this B and move to the next state here. So what happens is this this double B will be here and this B will be coming here and Q4 will be here followed by two B's. At this point Q4 on B, what is Q4 on B? It is the B only. I have to write B on top of it and move to the left. Which state I am going? Q5. Okay. So I'll write here BB then q5 b. I'll write a capital B on top of it, and I'll keep it as such here. And q5 on b is nothing but I'll be writing capital B and moving to the left. I'll move to which state? Q3. So therefore I'll write here b, then q3 b, and this will be turned to capital B, and here also bb. Q3 on B is nothing but again I will reach to Q0, and it is right position, so I will move to the right position. So it will be BB and Q0 BB B. Then from here directly I have the final Hall state on capital B, so I will be writing capital B on top of that, and I will be reaching the final state. Okay, so here I'll have the B here and reach the final state QF BB. So it does not matter if you are still in the middle, because if you have reached the final state, that's enough for us. Okay, and rest of the things are B's, that means the string is valid. Okay, our fourth question is the variation of the palindrome question. So here we'll have the odd palindrome. Okay, so this is the question 4. We have to construct the Turing machine for the given language WC WR. Okay, and W belongs to A comma B star, and this is the odd palindrome. So let's consider an example and see how we can approach this question. So W can be any combination of A's and B's, so I'll take AB, and after that we have C, and after that the palindrome of AB, which is BA. So how will we approach this question is that here we'll have a blank space here. So the same approach, just that we have to include the C's, means whatever is needed for C to be included, that we will be including in the transition diagram. Okay, so we'll start from here A. After we encounter A, we will be searching wherever we have the next A before the blank space. Then after that we'll turn this into a blank space. This will be turned first. After that we'll come back and see which is the next letter. B will be turning into blank space, and come here and see which is the letter before the blank space. If it's B, we'll turn it into blank space, and after that we'll come here and see if only C is left. If C is only left, we'll move to the final state. Okay, so this is how we'll approach this question. So let's make the transition diagram. So what is our starting state? Our starting state is Q0. So we'll make here Q0, and from Q0 either I can have A or I can have B, right? So what I will do, I'll make the possibility for the A transition as well as for the B transition. Let's focus one at a time. So let's consider A as an example. So suppose that this is the same string here, A B C B A. If I have A, what I will do, I will put a blank space on top of that and move to the right, and I will ignore the n number of B's, A's or C's. So in this state I have to ignore those things, means how many A's I get, I'll write A on top of that and move to the right. If I get B, I'll write B on top of that and move to the right. The same thing goes for C also. After that, when will I turn back? And when I encounter a blank space, right? So what I'll write here is, if I encounter a blank space, I'll write a blank space on top of that and move to the left, means come back to the previous position. At this position, if I have started from A, I have considered the case for A here, right? So when if I have taken A here, before the blank space I need A. So at this position, what I will check is if it's A or not. If it's A, I'll move to this state. I'll write a blank space on top of that and move to the left, and this state is Q3. Okay, here also again, since I'm coming back from here, I'll ignore the n number of A's and B's until I A, B and C, all I will ignore until I reach a blank space. Okay, so here I will ignore the things here, which is L. We are moving left side, so we have to write here L and L. Okay, we have written this for the A transition. Same thing goes for B also. Let's write here for Q4. Here I'll ignore the n number of A's and B's as well as C's. So I'll write here CCR, and whenever I encounter a blank space, what I have to do, I have to write the blank space on top of that and move to the left, and in this state I have to check if it's B or not. If it's B, I'll continue. Okay, so if I have a B here, I'll write a blank space on top of that and move to the left, and after that I'll ignore a number of A's and B's. When will I come back? I'll come back whenever I encounter a blank space, right? Means I'm coming here ignoring the n number of A's, B's and C's from here. Whenever I encounter a blank space, I have to start from this state to start the process for the next letter. So what I will do, I'll come back here. Fine, I'll write here B on top of, I'll write blank space on top of blank space and move to the right. So next I'll be at this position. After I encounter blank space, I'll move to the right and be in this position. Then I'll check for this one. Okay, So that's what I'm doing here. I'll be checking for B. When all the things are over, at the last, this will be cut and it will be BB, and I'll come back at this position. I'll be in Q naught, and after that, when I move right, I'll be encountering C. Whenever I encounter C, what I have to do, I have to move to the final state, because that's the final state. If I encounter C, I'll be writing C on top of that and move to the right, and I'll reach the state Q6. After that, finally, I have to write a blank space on top of that and move to the right, which is the final state. Okay, this is the final state. I'll move to the right. If I encounter C, what I will do, I'll move to this state, and in this state, that means I am moving right. See, from C I'm moving to the blank space, and whenever I encounter a blank space and I have no more letters to be processed left, at that time what I have to do, I have to reach the final state. From here I'll reach the final state QF. Okay, so this is the transition diagram. The instantaneous descriptor will be a big one, because this is a bit bigger transition diagram, so I'll be skipping that from now on. The working is the same. You can refer to the previous questions. Okay, our next question is regarding the odd or even palindrome. So here the difference is that in this question we'll have both the transitions for odd and even palindrome. For example, in the previous cases, what we had, either we had A B B A, this is for even palindrome, or we had A B C B A. Okay, this is for the odd palindrome. So in this question we'll be having both the transitions. So for that, in the middle position we'll have, instead of C we can have either B or A. Okay, so the transition will be A B B B A or A B A B A. Okay, so this is the middle element which is getting changed. So how can we accommodate the changes for the middle element? In the previous case, if we had C, we had gone to the final state, but we can't say for sure that this is the middle element, right? So we need to do something. Why we can't say for sure this is the middle element? What if the string itself is repeated again? See, if this is the case, A B A B A. So this is also a valid palindrome, right? How can we say it is the middle element? And in case if it's a even palindrome, there will be no middle element. So how will we make the changes for that? So for that, what we are supposed to do is that whenever we encounter A or B, what we do, suppose that the string is A B A B. So here the middle element is this one, and we have A and A here. Firstly, we'll start from here. We'll change the A here to the blank space, and then keep on moving until we reach the blank space here. And the letter behind the blank space is the letter to be considered. Here it will be become a blank space. Then again we'll come here and see the next letter, which is B, and this will be converted to blank space. And if we encounter blank space after a blank space together, what does that mean? That means that we have ended the string. There is no more letters left, so we have to move to the halt state. Okay, which means the final state. So this is how we'll approach this question. And if it's an even palindrome, we have the same thing as the previous one. This will be replaced by B, then this will be replaced by B, and after that, if we encounter a B after B, at that time what does that mean? The string is over and you have to reach the final state. So how to make the transition diagram for this one? So firstly, what is our starting state? It will be always Q naught. So Q naught is our starting state, and I can either encounter A first or B first. So as previously, we will be writing here A and a blank space, then R. This for the A transition, and for the B transition we'll have B, B and R. Okay, so this for A transition and this for B transition. First let's consider the A transition. Here I'll ignore the n number of A's and B's, so I'll write here AAR and BBR. Okay, and here also let's do that after the A transition gets over. We'll come to the B transition. So here we'll ignore the n number of A's and B's, and after that what we'll do, we'll write a blank space on top of blank space and we'll move to the left. Okay, so this will happen when we encounter the last B here, and we'll move to the previous state here. And in this state, if I had encountered A, I should encounter A again here. So what I will do, I'll write here blank space on top of, if I encounter A, I'll write a blank space on top of that, and I'll be moving to the left. Okay, so Q3 will be here, and after that Q3, and here it will be Q4. Okay, this for the A transition. I'll be encountering A, then I will be putting a blank space on top of that, and I'll be moving to the left, and here I'll be ignoring a number of A's and B's. Okay, so AAL and BBL. Okay, this is the same thing as we had done in the previous case. Same thing goes for here also. I have to ignore the n number of a's and b's, so I'll be writing aar and bbr, and here I'll have bbl, and here I'll have in q5. If I encounter b first, I have to encounter the b again, so I'll be writing here b and the blank space on top of that and moving to the sorry, not right, it's left. Okay. So this will happen until we encounter all a's and b's, and here what we'll be having is bbr. If I encounter a blank space, I have to start from the next state and I'll be reaching here. Suppose that the next state I got here b. Okay, let's consider this one a b a b. Okay, here what is the case? Here first I will convert this into b, then I'll move here, ignore a number of a's and b's, I'll reach to the last state, and again I'll move to the left. I'm at this stage, and if I encounter a, I'll be replacing it with b, and after that I'll move here, and here I'll ignore a number of a's and b's. So after that, whenever I encounter b here, then I have to move to the q0 state. When I move to the q0 state, I have to move to the right, so I'll be at this position, I'll be encountering b. What I will do here, blank space, and then at this position I have to ignore the number of a's and b's, and if I encounter a blank space, I'll move to the left, and after that I'll stay at this position. Whenever I move to the left and I found again b here, at that time I have to move to the whole state. Why? Because all b's are only there. So here I don't have any transition for the blank space. See, what I mean is, I encountered a b here, right, when this was b, and after that I moved to the next state here after ignoring a number of a's and b's which were not here, and I moved to the next state b here. Now I am at this position. Now at this position I don't encounter any means at this position I have to have a transition for b also, but I don't have any transition for b here, it's just the small b. So if I encounter a blank space after a blank space, that means I have to reach the final state because the string is over, right? So how will I reach that? How will I reach the final state is that from here I'll have a transition for the final state from here as well as here. If I had a here, I'll be going through this path and reaching the final state, or else as in this case I had b, so I'm reaching the final state through this path. Okay, so the final state will be here qf, and I'll be reaching here the final state. And what if the string is like just a blank space? If the string is only a blank space, I should reach the final state directly, right? So that also I'll have here bbr. Okay, that I'll reach the final state here, and here I'll have bbr reaching the final state bbr. Okay, so this is the transition diagram, and the instantaneous descriptor also is the same as the previous cases, just a slight difference. So that's all for this question, and let's move on to the next one. The next question is we should have the number of a's and b's as same. Okay, so the next question, L is equal to NA, number of a's in W is equal to number of b's in W. Okay, and W belongs to a comma b, and this is the language which is given to us. You have to construct the Turing machine for it. So let's take a sample string here like AB. Okay, and here we will have a blank space. Now let's start from here, and I'll be writing the code here which will be considering a will be replaced by x and b will be replaced by y. Okay, so how we will be approaching this question is that firstly, whenever we encounter an a or b, whatever we encounter we'll make it as x. It's not fixed here, sorry. Whatever we encounter first, that will be x, and for the rest of the problem also it will be same thing. Okay, so what I mean is, for the first iteration I have encountered a, so a will be replaced by x, then I'll move here and I'll be searching b. Whenever I get a b, what I will do, I'll replace it with y, and again I will come back and search if there is any a or b here. It is not there, so I'll move to the front, and whatever I find I'll replace that by an x, and after that I'll move here and I'll see if I get b. Yeah, I got b here. I'll come back and see if there is any more a's and b's. If not, whenever I reach a blank space here, I'll move to the final state. Okay, so this is how we'll be approaching this question. Let's take another string here and discuss how it works. Let's take a b b a b. So here 3 a's are there and 3 b's are there. So this is the valid string, and here we have a blank space. Start from here a, and we'll replace it with x, and we'll move here and find b. We'll replace this with y. We'll move back here, and this is the first a, so we'll replace it with x, and we'll find b. We'll replace it with y, and again I'll come back and see if there is no more a and b, and I'll encounter a here. I'll replace it with x and I'll move here. This is replaced with y, and I'll see if there is any more a's and b's here. It's not there, so I'll move to the final state. So this is the approach of this question. So let's make the transition diagram for it. So what is our first state? As always, it will be q naught, and from q naught where I have to go. Firstly, I either can encounter a or b, right? There are two possibilities, either I can get a or b. So let's take the first case, a. One case will do for means first case we'll consider for a, we'll make the transition diagram, then we'll do for b. Okay, if I encounter a, I have to replace it with x and move to the right, and in q1 state I'll encounter n number of a's. What I will do, I'll just ignore it. So AAR, whenever I encounter a b, what I have to do, I have to replace it with y and move to the left. After moving to the left, I have to ignore n number of a's. Okay, after that I have to why I have to ignore n number of a's is because I have to reach the first a. See, what I mean is AA, BB, AB. So after encountering this one, so let's take here a and b for better understanding. Here a is there, okay, I have replaced with x, and I'll move here and replace it with y. Then I can't consider this a because I need the first a. How will I get the first a? It is after x. So whenever I reach x, I'll move to the first state and again consider the next a from here. What I mean is, I'll ignore n number of a's after the before the b. I'll move till x, and whenever I reach x position here, I'll move back to the starting state, x, x, r. If I reach x, I'll move to the right and start from here. Again this will be considered, and I'll be replacing this with a, and whenever I encounter b, I'll move to the left, and again I will see any more a's are there. Like that we'll keep on doing until we reach the final. And what we have to do is one more thing is suppose that we have this one here, a is there, okay. So what we have to do, yeah, a is here, okay. So this will be replaced with x, and I'll be searching y, I'll be searching b, b will be replaced with y, and again I'll come back here. While coming back, you can observe here I am encountering y, right? So this y also has to be ignored. So what I have to do, I have a transition for here, y also, which is to be ignored. Okay, also x is here, right? So when I encounter here x, at that time I'll come back here. So that's done here already. And yeah, whenever I encounter a here and I have put x here, after that when I am searching for b, when I am going in this way, at that time I am getting y also here. So that y also should be ignored, right? For the second x, what I mean is, suppose that this was not there, I had taken this x here and searched b, so this was done, only these two were done. Again I came back here. At this time when I came back here, I made this as x and I was searching for b. When I was searching for b, I encountered a y also here. So this y also had to be ignored, which is this state. From after marking x from the q naught, this is the q naught state. After marking x, I was going here. At that time I encountered b. So here along with the ignoring n number of a's, I have to ignore n number of y's also. So y, here I'll have y, okay. After writing y, here, I'll be moving to the left here, and this y will be ignored here. This is for the a transition, okay. Then for the b transition, I'll do the same thing here. Instead I'll have b, x, r. So as I told you earlier, whatever I encounter first, that will be considered as x, and from there the whole thing will be solving. For example, if I take b here, like baa, bb, okay, let's take baa, bb here, okay. So here 3 number of a's and 3 b's are there, so that's a valid string. Whenever I encounter b, I'll be replacing with x, and I'll search for a will be replaced with y. So here after I start from here, in this state I have to ignore n number of b's, bb, r. When I encounter b after b, I have to just ignore it because I need a, right? After this, whenever I get a, what I have to do, I have to replace with y and move to the left. I'll replace with y and move to the left as I have done here, whenever till I encounter x here, okay. So I'll be making a new state here, and I have to ignore the n number of before that. Let's take here another example. Okay, because in this example I can't depict the possibilities which are means what all can happen here. So let's take an example of bb, ab, aa. Okay, let's take this string here. This is replaced by x, and I came here. This is replaced by y. Again I came back here. I ignored a number of a's, means where was this happened after this position x, then this was ignored, and a is here. A is replaced with y, and at this position I have to ignore n number of b's. So here also I have to ignore n number of b's, right? So I'll be moving to the left, bbl. Okay, I've ignored a number of b's here, and again I came back to this position. Whenever I encounter again like an x, at that time I have to come back to the q0 state, right? Here what we'll be having is that after here when we encounter a, we are writing it as y, and after that here we'll be ignoring a number of b's and reaching x. Whenever we reach x, what we have to do, again come back to this state, right? So I'll be taking the transition from here, and I'll be writing xxr, and from here after we have written xxr, we'll be searching for a here. So whenever we encounter a here, we'll be moving in this direction, and we'll be ignoring this, means from here we'll be ignoring a number of a's and b's, and also while moving in this direction we have y here, right? So what we have to do, we have to ignore a number of y's. So we'll be writing here yyr and moving here, and at this position whenever I encounter an a here, at that time I'll mark it as y, and I'll move back here. Whenever I move back here, at that time I'll be encountering either ace or means either I'll encounter b or I'll encounter y, right? So whenever I encounter b, I have this transition for ignoring b's, and whenever I encounter y, that also I should have here, like yyl. Same thing as I have done here. Okay, I'll be ignoring those a number of y's and as well as a number of b's, and I'll be reaching this state. And from this state, after all x and y's are over, if I reach the blank space here, at that time I have to reach the final state. So what I will do, I'll take a transition from here, bbr, and I'll reach the final state here. Okay, so this is the transition diagram for the question where we have equal number of a's and b's. Okay, our next question is the Turing machine for subtraction. So the question is as follows. So we have been given with L, that is equal to 0 power m, then a separator 1 and 0 power n, and we have been given two conditions. If m is greater than n, means the value of m is greater than the value of n, at that time we have to get the result as m minus n zeros. Okay, m minus n zeros we have to get. If it is m is less than n, then we have to get blanks. Okay, so let me explain you what does this mean. So for example, if I want to subtract 3 minus 2, how can I do this using a Turing machine? Firstly, what I will do is I will have 3 circles here, and I have 2 here. I have to subtract 2, so I will have 2 circles here. Okay, so for this one I will convert into blank space, and for corresponding to this one I will convert into blank space. Then next one I will convert into blank space, and here also I will convert into blank space. Then whatever I get, the remaining is how many numbers of zeros are remaining, that is my answer. One zero is remaining, so the answer is 1 here. Let's take another example here. I'll take 5 zeros, and I'll take 2 zeros here. So 5 minus 2, I should get 3. So for this one I will get cut with this one will be this one. So how many are remaining? 3. So my answer will be 3. Okay, by counting the number of zeros. So this is the same thing which is happening here. 0 power m, 1, 0 power n. So let me give you an overview. Firstly, if m is equal to 3 suppose, and n is equal to 2. Okay, what we are going to do is 0 0 0 we'll have like this. Then here 1 is present, so we will have 1 here, and n is 2, so we'll have 2 zeros here, and after that we'll have a number of blank spaces. Means as many blank spaces as we want, we can have here also and here also. Okay, so this is the question, and how we will be approaching is that first when we encounter 0, what we will do, we'll convert it into blank space. Then we will skip the n number of zeros and ones. After the first one, when we encounter 0, at that time we have to convert this into 1. Okay, we'll be converting this into 1. Then we'll again come back here, and we'll see if there is any more 0. Yes, there is a 0 here, so I'll convert into blank space. I'll move here, skip the n number of ones here, and after that the next one I'll convert into 1. After that I'll come back again here. Here it is 0, so I'll have to convert into a blank space. Then again I will move. I don't find any more zeros. If I don't find any more zeros, what I have to do, I have to come back here, convert this into blank space, convert this into blank space, convert this also into blank space, and the last blank space where I encounter, at that time I have to convert this into 0. So as you can observe, we have b's here, 2 b's, here 1 b, here 2 b, and here 3 b's. So in between we have just 1 0. So that is the final answer, 3 minus 2. Suppose that instead of 3 minus 2 I had written 2 minus 3. M is equal to 2 and n is equal to 3. Okay, so this is not possible because I'll get the answer minus 1, and minus 1 zeros cannot be represented visually, right? So at that case, what I have to do? Let's draw that. M is equal to 2, so we'll have 2 zeros first, then we have a separator here and 3n. Okay, so I have this one. So in this case, how the Turing machine will be approaching is, firstly this will be converted into b, then I'll ignore the n number of zeros. 1 after the first one, I'll convert this into 1. Then again I'll come back, convert into blank space. Again I will go and convert this into 1. Again I'll come back and see there are no more, means here no more zeros are there, but I have which state I came from. I came from this state. After converting this into 1, I came to this state. In the previous case I reached here, then I came here. Okay, that is a different scenario. In the previous case I had reached the blank space, then I reached here, but here before reaching the blank space only I reached here. That means this is smaller number, this is greater number. Here only 2 zeros are there, here 3 zeros are there. If in this case we reach like this, at that time what we have to do, how many ever we encounter ones and zeros, we have to convert into blank space. Okay, so the final answer will be all blank spaces. That's what they have. What they have given in the question. If m is greater than n, m minus n zeros should remain. If m is less than n, all the it should be replaced with all the blank spaces. Okay. And there is one more scenario. Let's consider that one. Like if you did not understand how this 1 0 came at last, let's take a bigger example. In the bigger example, I'll take m as 5 and n is equal to 2. In this case, hopefully you will get to know what I am doing. If m is 5, it will be having 5 zeros here. Let's make 5 zeros, then 1 separator and 2 zeros here, then a blank space. Let's take some blank spaces here. Okay, so I'll be starting from here. This will be converted into blank space. Then I'll move on, ignore the n number of zeros. When I reach 1, after that the first 0, I'll be converting this into 1. Again I'll come back, convert the second 0 into blank space. I ignore the n number of zeros and n number of ones here. After the last one, whatever I receive is that that should be converted into 1, and after that again come back, convert this into blank space. See, I'm converting an extra 0 into blank space because we don't know what is remaining here. After this it can be 0 also, we have not checked that. So that's why I'm converting this into blank space. Whether this is valid or not, at the last we will know. Okay, so that's why at the last what we will do, the last blank space will convert into 0, like how we did here. At last we reached here, it was a blank space, again we converted into 0, right? Why? Because I had converted this into a blank space by assuming that there is another 0, but it was not there. So since it was not there, my assumption was wrong. I should revert my assumption. That means I have to make the blank space again as 0. So this is the answer. So what we basically do is, for each zeros here, we'll be cutting the equal amount of zeros, and whatever the zeros remain here, that's the answer. So this is my assumption that there is a 0 here, so I have converted this into blank space. Again I'll keep on checking if there is any other 0 or not. There is no more zeros. When there is no more zeros, what's my task is, I have to convert all the other values into blank space, as I did here. I reached here, I did not find anything, so I'll convert the previous values into blank spaces. So I'll do the same thing here. I'll come back here, convert into blank space, and convert this also into blank space. Then I'll convert all the ones into blank spaces, but the zeros will remain because that's my answer, right? Here there are 5 zeros, here there were 2 zeros. I cut 2 zeros for these 2 zeros. This one was for assumption. So for assumption I came I came to know here that that was my wrong assumption. So I should come back and revert this assumption. So when I am coming back, all the other things should be blank spaces, because only zeros should remain. So therefore I am converting all the ones into blank spaces. Again I will come back here, and zeros will remain as such, and the last blank space will be reverted back into 0. So I will have 3 zeros here. So this is the working of the Turing machine. Let's make the transition diagram. Okay. So what will be my first step in the transition diagram? Let's take an example here and understand how to make the transition diagram. Okay. So the example I will be taking the same like m is equal to 3 and n is equal to 2. Since you have got the concept, I will take a smaller example. So 0 0 0 1 0 0 and a blank space. Okay. So this is the question, and we'll start making the transition diagram. What was my first step? I'll start from q0, and when I encounter 0, I'll encounter 0 at the first. So therefore I have to convert that into a blank space and move to the right. Okay. And after that I reach q1 here, and here I should ignore a number of zeros. So therefore I'll have a self loop here 0 0 r. Then when I encounter 1, I should move to the next state. It will be 1 only, 1 1 r. When I move to the next state, here what I have to do, the first 0 should be converted into blank space, right? So I'll move here and convert the first 0 into blank space. Then I'll move to the left, right? So if I convert the first 0, sorry, the first 0 should be converted to 1. Okay, the first 0 should be converted to 1, and I should move to the left. Okay, so this is q3. Okay, you understood, right? What we did, first 0 was converted to blank space, we moved here, ignored n number of zeros. When we encountered 1, we moved to the next state. In the next state, when I encounter the first 0, at that time I have to convert into a 1 and move back to the left. In the left, if I move, I'll encounter again 1 here. So I should ignore n number of 1s. 1 1 L. When I encounter 0, that should also be ignored. 0 0 L. Until when I should ignore? Until I reach the blank space. When I reach the blank space, I have to move to the right. Okay. When I suppose that I'm in q3, 0 0, again I came here. Now I'm in q3 state, and the input is b. What I have to do, I have to rewrite b on it and move to this position, right? So what I will do, again I'll come back here. Why? Because the same story is getting repeated again here, like q3 bbr. I'll write b on it, and again I'll move to the right, right? So after I come here again, that's the same thing which I had already done. It's happening again. So why to make another states? We can just repeat the same process here. So here again 0 will be converted into a blank space. I'll move and ignore a number of zeros here. Then I'll move to the, when it's 1, I'll move to the next state. Here again I have 1. So I have to have a loop here, 1 1 r, ignore all the number of 1s here, and when I encounter 0, that should be converted to 1 and move left. This will be converted to 1 and move left. Here I'll have again 1 and another 1. 2 times 1 is there. So that will be ignored by the self loop. And when I encounter again here 0, at that time I have to convert into a blank space, and again I'll move here. Okay. So and ignore a number of 1s here, means sorry, there is no more 0. So this state will not work here. I'll directly move to the next one after the first one, and another 2 1 will be ignored by this one. So after that I'll reach the blank space. After this point I am reaching the blank space. So what does that mean? That my string is over. So when I reach the blank space after q2, what I am supposed to do is I have to come back. Where I have to come back? I have to convert all the ones what I have present here. That all one should be converted to blank space. So I'll move to the next state. Actually I should have drawn in a different way, but it's okay. You got the point, right? What I'm doing. Why I'm coming to the new state? Because I have reached the end of the string. And here whenever I encounter 1, it should be converted to blank space. So the first one I encounter, it will be converted to blank space and move to the left. How many ones I encounter? That all should be converted. So I'll make a state here with the self loop 1bl. So after the n number of 1s here, if there is any more 0 remaining, that will remain as such. So 0 comma 0 comma left, and when I encounter the first blank space, that means it was my assumption. My assumption got wrong. It should be reverted back. Reverted back means this blank space should be reverted back to 0, right? Because I have assumed that there is another 0 here. That's why I made this 0 as blank space, but that was false. So therefore I have to remove this blank space and make it as 0. So from here I'll make it as if I encounter blank space, I'll make it as 0, and I'll move to the right, and yeah, that's it. That's my final state here, QF. Okay. Now this was for the case when we have m is greater than n. What if m is less than n? That means if m is equal to 2 and n is equal to 3. At that time, what is the thing which we need to consider? Let's take that string m is equal to 2 and n is equal to 3. Okay. Here from 0, I'll go to blank space. Okay. Here I'll ignore n number of zeros. I'll move to the next state. Here also I'll ignore the n number of ones, but I don't have any 1 here. The first 0 will be converted to 1 and I will move left. While moving left, I'll ignore the n number of ones here, and after that, when I reach, I'll ignore n number of ones and zeros. When I reach the blank space, again I'll come back here, rewriting b on b. I'll rewrite b on b, and I'll come to this state. And here I'll do the same thing again, b, and I have encountered 1 here. 1 will be moving here. After that, I'll ignore n number of ones here, so I'll ignore that. And when I reach this 0, it will be converted to 1, and again I'll move back. Observe here, I'm moving back, and I don't have any more zeros here from this state, not from the blank space. In the previous case, this one was over. Why? Because here more zeros were there, here less zeros were there. So this one will get over, and I'll move back from b here. In the case when m is greater than n, here 3 zeros were there, here 2 zeros were there. So this will get over faster. I'll move back from this state, but here this zeros are over faster than this one. So I'm moving back without reaching blank space. So here different things should happen. So what will happen is I've converted this into 1. I'll move to the left, ignore n number of ones and zeros. So I'll ignore that, and again BBR. So I'll write B on B. Again I'll move to the right. Here from this state, I need to have a transition for 1. I rewrote B on B. From this state, again I moved back here. In this state, what I'm encountering is next one is 1. But I don't have any transition for 1. So if it is 1, what does that mean? It means that I have come to the end of the state. Means this one is over, this is lesser, and this is more, right? So if that's the case, what I have to do, I have to convert all the things into blank spaces. That means from this state, what I will do, Q0, I'll move to a different state, which is Q5. Let's take. Here what I will do, I'll convert all the ones into blank spaces and move right, convert all the zeros into blank spaces and move right. So this will be converted to blank space, blank space, blank space. And when I encounter the last blank space, what does that mean? The string is over. So therefore, from this I'll move to the halt state. Okay. So this is the halt state here, and I'll rewrite b on b and move to the last state. Okay. The next question is regarding the Turing machine for multiplication. So what we have is, if we have been given with two numbers like 3 into 2, okay, and we will get the answer as 6. So how can you perform this multiplication using Turing machine? That's what our question is. Okay. So 3 I can write like this, and 2 I can write like this. Okay. So finally I should get the answer as 6. That means 3 should repeat 2 times. So what I will do, I'll start from here, I'll make a sign here, then I'll move to this one, I'll make a sign here, then I'll move to this one, I'll make a sign here. After one time it's over, again I will reset back here. Okay, one time it's over, again I will start from here, I'll make a sign, again I will start from here, make a sign, and this one also I'll make here. Second time it's over. So how many ones I have here? It's the total number of ones I need, which is 6. Okay, so this is how we will be performing the multiplication for Turing machine. So let's write the question. L is equal to 0 power m, 1, 0 power n, and 1 blank space, and m into n is equal to number of zeros. Okay, so this is our question, and let's take the value of x as 2 and y as 3. So xy will be equal to 6. Fine. Let's move to the further steps in the question. What we have to do is, see here, let's write down the string. W is equal to 0 0 0 1 0 0, then blank space. This is what we have. So m is equal to 3 and n is equal to 2, and the final answer what we have to get is 6 zeros here. Okay, so and only 6 zeros we will have, rest all the things, ones, zeros, everything will become blank space. Okay, so let's start what we have to do in this question. Firstly, we'll start from here, and whenever we encounter a 0, we'll make it as blank space, and then we'll move here, keep it as such, and we'll move here, keep it as such, and we'll move here and keep it as same. And when we move here, at that time I'll make it as 2. Okay, why 2? Because it's the first time I am going from here, means I have to repeat this one 2 times, right? So I'm just changing the sign. You can make it as 3, 4, 5 or any other symbol also. Okay, just for knowing that the symbol has changed. Okay, then I'll keep it as such, and here when I come, this first blank space will become as firstly there will be n number of blank spaces here. Okay, this blank space will become as what we need at the end, we need as 0, right? So it will become as 0. After it has become as 0, the rest will remain as blank spaces only, and we'll move back. When we move back, at that time 1 will remain 1, 0 will remain 0, 2 will remain 2, 1, 0. When we reach the first 0 here, this will also this will also become as blank space. So when we make the second 0 as blank space, I need to get that 0 reflected here. So I'll keep all the things as same, and this will become as 0. Then we have BB, BB. Then again we come back here and make the third 0 as blank space, and then 1, 2, 0, 1, 0, 0. This blank space will become as 0. Then B, B, B. Okay, so this is what we have reached till now, and after that what we are going to do is we'll be again resetting this back to zeros. Why? Because we have just done it for once, right? So we need to reset it all back to zeros, so that we can again do the same thing, like add the 3 zeros here. Okay, so for that what we are supposed to do is, firstly we'll be coming back here, and when we reach this position we'll convert this into 0. Okay, so when you come back here and we'll make this as 0, this also is 0, and this also as 0. After we have done that, we'll again do the same thing, 0, 0, 0, B, B, B. And again what you have to do, we'll come back again here and we'll start converting this into blank space, and we'll make this 2 as means 0 as 2, 2, 2, then 0, 0, and here it will be 0, 0, 0. First blank space will be converted as 0. In the second iteration, second blank space. In the third iteration, third blank space. Okay, so after that when this all is done, we'll convert the remaining things into B's. Okay, so we have 6 zeros here. So this is one of the approaches, and the transition diagram which I am going to make is a slight different from this one. So if you have understood this one, you will be able to understand in the next one. Okay, the actual answer which we are gonna make the transition diagram for is, it will be like this, just a slight difference. Firstly the initial strings let me make, there will be blank spaces here. Okay, what we are gonna do is, first it is 0, 0 is here, right? For the first iteration, this is how my approach will be, 3 into 2, that is equal to how much? Okay, so for the first one what I will do, I will convert it into blank space, then I'll draw these 2 here. Then again second one I will convert into blank space, again draw these 2. Third one also I will convert into blank space, and again I will draw these 2. The answer is same, right? What I am doing is 3 times I am making 2. In the previous case what I did, 2 times I made 3, right? So here it's a slightly different. So this approach will give us the answer in a very easier manner. Okay, so if you have understood this one, this will be very easy for you. Okay, so first I'll make this as blank space, and after I made this as blank space, I'll ignore the n number of zeros here, and ones also, and the first 0 which I encounter after 1, that is I'll change the symbol. Okay, I'll make it as 2 or something. Okay, after that I'll keep this as same, and after that when I encounter the first one here, after that the thing should become as 0. Okay, after this the things will remain same, and I'll come back from this state. When I come back from this state, when I encounter the first 0 after 2, at that time I should convert this also as 2. Why? Because I have to make the 2 zeros here, right? Only 1 0 is made. For the second 0 I'll convert this also. So let's do that. I'll make this as 2, and after that, because I made this as 2, I have to change this blank space into 0. So I'll make it as 0, and the blank spaces will remain like what was before, it will remain as same. Okay, so after that I have made this 2. If I get a 2 and 1 together, at that time what it means is the string is over here. So I should convert this back into zeros and move back to the first iteration. Okay, So here I'll come back and I'll make this as zeros. When while coming back, I'll check if it's 2 and 1 is on the same means together. That means the string is over. I have to convert this into zeros, and after converting that into zeros, I'll come back here, and the second zero I'll make it as blank space. Okay, the rest of the things are remaining same. So what I did is I just came back here, made this as zeros, then I came back here. The second zero I have to process. I have to make means what I did for the first iteration I have to do for the second iteration. That's why I made it as blank space. The same thing I'll do again. I've made this as blank space. So therefore my task is to convert this into 2 and convert this b into 0. Again I'll come back, I'll convert this into 2, I'll make this blank space as 0, then the rest of the things will remain same. After this is done, again I'll come back and convert these two into zeros, and I'll make this as blank space 1 and here 1. Since I have made this as blank space, I have to make these two as 2 and add 2 more zeros at the end. So that's what we will be doing here. Here what we have is this will be made as 2, and here this b will become as 0, this will become as 2, this b will become as 0, and here the rest of the things will remain same. After that, when I come back from here, okay, when I come back from here, at that time what I notice is this is together. That means I have to convert this into zeros. I'll convert that into zeros. When I come back here, I find that after blank space it is 1. That means the first string is over. That means how many times I had to insert zeros here, means 3 times I had to insert 2 zeros. That is already done because all are converted into blank spaces. That means my string is over. At that time what I will do is I'll start converting all of these into blank spaces, okay, except these things. Here it will be the same thing, and when I reach this position, at that time I will move right and convert this into blank space. Okay, so this will be converted into blank space, this any number of zeros and ones. After the second one it will be stopped, okay, and this will be remaining as zeros. I'll be passing through the zeros, and finally I'll be reaching the blank space here. If I reach the blank space, that means I have reached the end of the string. Okay, so this is my answer, 6 zeros. Okay, so this is our approach of this question. So let's make the transition diagram. So let's keep this as a reference, and by looking at this we'll be making the transition diagram. Okay, so let it be here, and we'll refer it when we need. Okay, so firstly let's start from here. Now the first state is q naught. Okay, and this is our string 000. Let's write it here. Okay, and number of blank spaces here. So what is our first step? Our first step is to convert this into blank space. Okay, whenever we encounter the 0 in the starting, so we'll be converting that into blank space and moving to the right, and after that we have to ignore the n number of zeros. So here in the q1 state I'll have the state as 00r. So after that, when I reach 1, I should change the state 11r, and I'll reach the state q2. In q2 I have to make the first 0 which I encounter as 2, right? So what I'll do is I'll write 0 comma 2, and 0 will be converted to 2, and we'll move to the right. Okay, so this will be made as 2, and we'll move to the right. Here also it should ignore n number of zeros. So in the q3 state I'll have 00r. So it will ignore n number of zeros here, and after that when I reached 1, I should change the state. So I'll change the state in this way. I'll reach 11r. So I'm here at this position now. So after the first one, if I encounter a blank space, that should be converted into 0, right? So in the q4 state, I'll be, if I encounter as b, at that time that should be converted to 0, b comma 0, and I should move to the left. Okay, I should convert this into 0 and move to the left. Then if I encounter as 1, what I should do, I should just ignore. I'll just do q5 as 11l, and when I encounter after that, if I encounter as 0, that should also be taken as 00l. Okay, so after I've ignored a number of zeros and ones, if I encounter as 2, at that time I should change my state. If I encounter 2, what does that mean? Where I am starting from again. If I encounter 2, my next step is convert the next 0 into 2, move here, again change the blank space. So this is a repetition here. firstly before also I have done the same thing. I've reached some state in that 0 was converted to 2, and I did the same thing here. So which was that state? It was this state, right, from Q2. So I'll be making a connection here, which will be this 0 will be if I encounter 2, I'll be keeping it as 2 only and moving to the right. Okay. See here, from here I reached here, I encounter 2, I'll be writing 2 on top of it and I'll move to the right. The next is 0, this should be converted to 2. That will be handled by this one. So this will happen until all the zeros are over here, and after that when I reach a state here, when all the zeros are over, at that time, what will be the next step? What will be the next string here? It will be 1. So instead of encountering 0, I'll be encountering 1 here. Okay, if there are no more zeros, I'll be encountering 1 here after 2. So if I encounter 1 here, what should I do? At that time, my next step is I'll keep 1 as such and move to the left. Why I'm doing that is because I have to convert the 2 into zeros again, right? I have to restart it. So in this state, like Q6, what I will do is, how many ever I encounter as 2, I will make it making it as 0 and moving to the left. So this will be converted back to 0. This will also be converted back to 0. Okay. So after that I reach 1. 1 I should keep it as such, I should not do anything. 1 1 L and zeros also 0 0 L. Now what if I encounter B? If I encounter B, at that time I should again write as BBR, right? Now you'll understand. I am after this I'm just repeating the same thing what I've already done, right? If I reach this state, this B, I'll write B on top of it and move to the right. Then I'll start the process from here. So I'll write BBR, and from here I'll start the same process again. Convert this into B, make this as 2, make this as zeros, again come back and do the same thing. So that is repeating here. So this is the which state I am encountering 0 and converting into B, that is Q0. So I'll go from here till Q0, 0 will be converted to B, and I'll reach here, ignore n number of zeros, and so on. So this process will repeat. So it will repeat until all the zeros have converted to B, and after that what I have to do, I am encountering, after B I am encountering 1. So at this point I am not encountering any more zeros. Here no more zeros are there. What I am encountering is 1. So if I encounter 1 here, that means the string is over. So what I will do, I have to convert the remaining things into blank spaces. So 1B R. 1 will be converted to blank space and move to the right. The n number of zeros and will be converted to 1, blank space, and 1 should not be converted right now. Okay, the remaining zeros will be converted to blank space, 0 comma B R in a loop. After that is over, in this state I have to convert this into blank space, but I have to move to the next state, 1 B R. So this will be converted to blank space, and these are also blank spaces. So after that I have the answer here, 6 zeros, and after that blank space is there. So when I reach this point, at that time I have to reach the final state. That means my my string is over, and these are the B's here, and how many zeros are there, that's my answer. So this is the final state. After this point I'll reach the final state. So I'll write here QF. Okay. Since this is the bit lengthy one, to give you a better understanding, I'll be taking the instantaneous description. Okay, because in exam anyway you have to write. Okay, so if you want to have a look, you can have. Okay, so we'll take the string 0 0 and 1 0 1 B, a small string. Okay, so let's write the instantaneous description for it. Where we are starting from? We are starting from Q0. So what we'll write, Q0 0 0 1 0 1 B, and this is the instantaneous description symbol. Okay, and Q0 on 0, what's happening on Q0 on 0? It is converted to blank space, so we'll write that first. Let's do it step by step. Convert this into blank space, and then what's my next step? Move to the right. Move to the right means this will be moved to the right. So when I move this to the right, B will come here. Q0 is moved to the right. And which state I am moving to? I am moving to Q1. So I should make here Q1. Okay. Then what is the next thing? Here I have to ignore n number of zeros. So therefore, I'll be writing the same thing. I'll be ignoring n number of zeros, and where I have to move to the right and stay in the same state. So 0 will come here, Q1 1 0 1 B. So Q1 is here now. I am encountering 1. That means I have to change the state q2 and move to the right and keep it as 1 only. So b 0 1 will be same, and I have moved to the right and my state is q2. Okay. After this point I am encountering 0 here. I have to make it as 2. That's the thing. If I encounter the 0 after the first one, that means it should be converted to, and another 0 should be made here. So let's do that. B 0 1, this will be converted to 2, and I'm moving to the state q3 1b. After the state q3, if I encounter 1, I have to change my state here. I'll change my state as 1, and I'll change my state from q3 to q4. I'll move to the right and I'll keep it as 1 only. So b 0 1 2, and here 1 will come, q4 b. And after that q4 on b, what does q4 on b? It will be converted to 0 and move to the left. Okay. So the first b after the second one is what I have to convert to 0. My final answer will be here. Okay. So it will be 0 1, and it will be moved to left. My state is q5, and I've converted this into a blank space 0. So I'll have 0 here. Let's add the blank spaces here. You can have n number of blank spaces here. Okay. So let me keep it as such here, and after that q5 on 1, what I have to do, I have to just ignore it, move to the left. B 0 1, move to the left means q5 will come here, q5 2 1 0, then b is here. Okay. And after that q5 on 2, what is q5 on 2? I have to move back to q2. Why? Again I have to make it as 0 and move back and make this as blank space. That's why I'm moving towards the second iteration. So I'll have here as 0. This will be q5. Sorry, I'm in q. From here I went to q2, right? So I'll be in q2, and this will be converted to 0 1 0 b b b b b. q2 on 0, q2 on 0, it goes to q3, and it will be converted to 2. So no, I guess something has gone wrong here. See, 1 is here, right? I forgot to put this 1 here. So 1 will be here, and q2 on 1. What is q2 on 1? I'll move back left and keep it as 1 only. I'll move to state q6. So it is q6 0, and here I'll have 1 0 1 0, and these are the b's. So here I'm encountering q6 on 0. q6 on 0 means keep it as 0 only and move to the left. Same state, keep it as 0, move to the left. I move to the left, same state, keep it as 0 and 1 here. Okay. And after that q6 on b. q6 on b means again come back here, process the second 0. Okay, that's what it means. Come to q0. So it will be b, then it will be q0 0 1 0 1 0 b b b b b. And what is q0 on 0? q0 on 0, again will be doing the same thing. Let's do it with our mind only. What we'll be doing here, b. q0 on 0 means I'll make it as b. I'll move to q1 and write 1 0 1 0 and b's. After that, what we have to do, b b, q1 on 1, I'll change my state. I'll move to the right, I'll keep it as 1 only. q2 0 1 0 b b b b b. So as you can observe here, after the first one, this is the 0. This should be converted to 2. So I'll move to state q3, and I'll move to the right. So it will be q3. This is converted to 2, and I'll have b's here. After that bb 1. What is q3 on 1? q3 on 1, I guess we have to move to the right, keeping it as 1 only, and we'll move to the state q4. So it will be 1 only, and we'll move to the state q4 0 b b b b b. After that we have to ignore n number of zeros here, as I have written here. I am in q4, right? At this point I think I have missed something. I have to ignore n number of zeros here. Because why? Because after this point I have converted the first 0 here, and after that I need a blank space. So obviously I encounter n number of zeros here. So that should be that transition should be mentioned here. So just make the changes here. 0 0 r. Okay, after ignoring n number of zeros and staying in the same state, when I encounter a blank space, what I have to do, I have to change the state as change this as 0 and move to the next state. Okay, so bb 1 2 1 and 0, q4 on b is q5 and b will be converted as 0. I'll move to the left. So if I move to the left, the 0 will come here, I am here, and here the b's are there. Okay, so this is what happened. Q4 on b will be converted to 0. I'll move to the left and the state is changed as q5. Okay, so this is the thing here, and after that I'll ignore a number of zeros and ones, and 2's will be converted to zeros. Okay, so bb 1 and q5 1 0 0 b. I think we need not write any more b's because this is the final answer. And after that we'll come back here again, bb 1 q5 2 1 0 0 and 1b only will write. Okay, so here q5 on 2, what is q5 on 2? q5 on 2 will reach this state here 2 to r. Okay, so let's write it here. Which state I am in? See, it was the previous step I am writing here, q5 2 1 0 0 b. Okay, what is q5 on 2? I'll reach back to q2. Okay, so b and I'll move to the right, so it is 2 q2 and here it is 1 0 0 b. q2 on 1 means keep it as 1 and move to the left. bb 1 2 and which state I am going? q6. So 1 and move to the left, that means q6 will come here. Okay, see, q2 on 1 means move to the left on q6. So I move to the left, 2 came after this one, and which state is this one? Change to 6. Okay, rest is same. So q6 on 2, make it as 0, move to the left. bb q6, I have moved to the left, 1 will come here, this was converted to 0 because of this one, and here I'll have 0 0 b. q6 on 1, keep it as 1 only and move to the left. q6 b 1 and 0 1 0 0 b. What is q6 on b? q6 on b, I'll move back to the initial state. So I still don't know that there are any more zeros or not, so I'm moving to this state. At this point I'll compare if I have to go in this way or this way. It can be either 0 or 1, right? That's why. So b and b q naught 1 0 1 0 0 b. At this point I have to decide if there is any more 0. At that time I have to make 2 more zeros here, right? So sorry, not 2 more zeros, 1 0, because I am repeating this one here. Okay, so since there are no more zeros, I am encountering 1. What does that mean? My string is over, means the outer string, the first string is over, so I need not perform any more repetitions here. So what I will do is, from here I'll move to the q7 state. Okay, so here I'll make it as blank space. See, we have to make it as blank space. 1 is converted to blank space, move to the right and q7. Okay, first convert this into blank space, move to the right and the state is q7, then 0 1 0 0 b. This 0 should be converted, all the zeros should be converted to blank space, move to the right. b b b, this should be converted to blank space, move to the right and same state, 1 0 0 b. q7 on 1, q7 on 1, I have to move to the final state qf, and it should be converted into blank space, the 1. Okay, so it will be b b, and this will be converted to blank space, move to the right, this qf, and I have 0 0 b. So I've got my final answer after reaching the final state. How many zeros are there? 2 zeros. Okay, what was the number I had taken here? 2 zeros, so m is equal to 2 and n is equal to 1, so 2 ones are 2. I have 2 zeros here. Okay, the questions which we had discussed now are the most important questions from exam point of view. So practice those questions and accept those questions. There is some theoretical concepts. So and before discussing a theoretical concept, I will be discussing 3 questions which are not directly related to what all we have solved, but they are a bit related, and they have to do more with the like previous what we had learned, that one in the first module. Okay, so let's discuss. These are very short questions. So the question is that concatenate w1 is equal to 1 1 and w2 is equal to 1 1 1 1. Okay, so if they ask you a question of this type, what you have to do is, this is 1 1, right? So you'll write 1 1 b, and here you have 4 1s, so after that you will write 4 1s and you'll write a b, and starting will have a number of b's. Starting will have infinite b's, but that is not considered. What is considered is, we'll start from this one. So whenever we encounter 1, what you have to do, we'll keep it as 1 and move to the next state. If you encounter 1, keep it as 1, move to the next one. If I encounter b, change it to 1, move to the next one. All the ones will be kept as such, and when we encounter the last b, what we have to do, we have to keep it as b and move to the left. And the which is the one which is most near to the last b, that is also converted to another b. Why we are doing is because this b was converted to 1, therefore this one should be converted to b, to keep the count of ones as same. So we'll come back here, ignore all the n number of ones here, and after that this b will remain as such. Okay, so now you only count and say me how much ones are there. 2 ones and 4 ones, so total 6 ones should be there. So 2 ones and 4 ones are here. So this is concatenated now. So that is our final answer. So let's see how to approach this problem. So firstly, in the first state, we'll start from here. We'll ignore a number of ones here by writing 1 on top of it and move to the next state. When we encounter the first b, we'll convert that b into 1 and move to the next state. Here we'll ignore a number of ones, so 1 1 r, and when we encounter the last b, what we have to do, we have to keep it as b only and move to the left. The first one which I encounter, that should be converted to b, so 1 will be converted to b and move to the left. And in this state, what I will do, I'll ignore a number of ones here, so I'll be having 1 1 l. Okay, and after that, after ignoring a number of ones here, this is converted to 1 here because of this one. I converted this this one. Okay, so here I converted this into 1 here, so this is my string. I am ignoring a number of ones here. When I encounter the first b after the n number of ones, that's my indication that the string is over, so I'll keep it as b only, bbr, and move to the final state. So this is the transition diagram for the concatenation. Okay, so the next one is the language which is given to us as w. W belongs to 0 comma 1 star and string ending with, they can ask you anything ending with. Okay, just know the algorithm how to solve this one. Whenever they ask you the question like this, your first step is to write the least string 0 1 1, just as how we did in the previous modules, right? That's what we did. We'll be writing the which is the least strings and all, and then we'll be starting from here. 0 1 1 is the least string. How many states you need? q0, you'll move from 0, then you'll move to q1, and here again if you get 1, q2 1, and qf. Okay, this is the final state. So this is the minimum thing which you have to do. After that, you'll add on top of this what are things required. Okay, so if you encounter 0, you'll write on top of it 0 and move to the right. When you encounter 1, you'll move right by keeping it as 1. Here also you'll do the same thing. You'll reach the final state if you get 0 1 1. What if now we have to define both, means all the states should have the possibilities of 0 and 1 both. So this has 0. What about 1? If I get 1, I can keep here only, like n number of ones can be in the beginning, right? And after that, if I get the first 0, after that I should have only zeros. I can have a number of zeros. After that, 1 1. If I get 1, that's defined for this one, and this is defined for 1. What about 0? If I get like 1 0 1, that is not accepted. If I get 1 0, again I am getting 0 here. What does that mean? Again I should come back. Whenever I get 0, I'll start from here to end with 1 1. So 0 0 r, and I'll keep on going 0 1 1. So in this way I'll reach the final state, and final state should also be defined for 0 and 1. If I get 0, I'll reach this state 0 0 r, and if I get 1, I'll start back from here 1 1 r, because if I get 1 here, I should have a 0 prior to it, but I don't know if I have 0 or not. It can be 0, it cannot be 0, both is possible, right? So I'll be starting from here again as a fresh new string. I should end with 0 1 1. Okay, so this is the transition diagram for the given language, and this is another language like L is equal to W, W belongs to A comma B, and it ends with A, B or B, A. Okay, so it either ends with A, B or B, A. What is the least string? A, B and B, A. These are two least strings. So we'll be defining the transition diagram as follows. We'll have Q naught here, and when I encounter A, I'll move to the next state, and here if I encounter B, I'll move to the next state, and here if I encounter blank space, because I should know that the string is over, right, because it ends with, right. Here also actually I should have had, but it's okay. Here I'll have B blank space, I'll reach the final state QF. Now if I get A, I'll write A on top of it and move to the right. If I get B, I'll write B on top of it and move to the right. Here blank space and right. Okay, this for AB. Now ending with BA. B, BR, I'll move to this state Q3. Here I'll get A, AR, and here I'll get Q4, that is BBR. If it ends with BA and the blank space is there, that means the word is ending with BA, and here I'll have blank space. So this is accepting for AB and BA. What about other strings like AAB, AABA, like that? Those strings, what you have to do? Here AA is there, so A, and again I can have n number of A's here, right? Because even if there are n number of A's, after that B is there, it's ending with AB. Same thing goes here. I'll have B and I'll have n number of B's here, it's ending with BA. Okay, so this is defined for AB and this is defined for A as well as B, and this is defined if I get like BA. If I get BA, I should reach the final state. From here, if I get A, I should reach the final state. That means I'll have a transition here, AAR, so that B, A and a blank space, I'll reach the final state. Now what if I get A here and I'll get B and I'll reach the final state? In that case, what I'm supposed to do is like this, B, B, R. Okay, like if I get B, then n number of B's A, then again I'll get B, then AB. You should not accept AB, right? It should accept AB. So A, B, then I'll reach the blank space. Okay, so this is for AB, and here from here also it's possible, right? See here, this is defined for A. What about B? If I get B here, another B, just consider this string ABB. A, then B, another B. I should define something here. If it is B, at that time I will come here. Why I'm coming here? Because if I come here, at that time, if the next letter is A, it will reach the final state with BA as ending. If it's B, the n number of B's will be self loop here. Same thing goes here. If I get like BA, BA, first B will come here, then A, then again I should define something for B here. That B is defined here like this, BB. Okay, sorry, B is already defined here, right? So what do we need here? A, I guess A is needed here. Like suppose BAA B. Okay, BAAB. So B A. So B A. Then again A should be defined here. So that I will define in this way. So it will be AAR, and that will come here, and B will come here. So AB, that's the ending, right? So yeah, that's it. This is the transition diagram. Just understand what is here. From here it is BBR, and from here it is AAR. Okay, rest all things you can understand. Fine. So this is the this is the numerical questions which are important from exam point of view. Now I'll be continuing with the some of the important theoretical concepts. Okay. Coming to the theoretical part of the module 4, we have 3 questions. The first one is explain the design of Turing machine. Okay, so Turing machine, we have all understood what is Turing machine. When there is a string, when there is a tape here, the machine processes on this tape and reaches the final state. Okay, means the blank space. So this is the diagram which you have to make first. Like you will be taking a tape here and the blank spaces here, and the control here. Okay, so this will be moving right and left. And what we will be doing is we will be either changing the state or moving left or moving right. Okay. So that are the rules written here. You have to write this diagram and write the rules, and after that you have to define these 7 tuples. You can go through it, and the Turing machine's representation you have to do. This is the third thing. Okay, 3 things you have to do. First you have to make the diagram and explain what are these things. Then you have to define it using the 7 tuples, and after that finally you have to say how it can be represented. Okay, there are 3 representations which we all are familiar with. The first one is instantaneous description, transition table, and transition diagram. In the instantaneous description, you'll have a set here, means a sequence of symbols here. Then you'll have the present state and which state you are processing it, and after that the further states are written. Okay, so q3 on a1, what is the result that will be making the changes? Suppose that q3 goes to right and a1 becomes a2, so a1 becomes a2 and q3 goes to, like, suppose q4, so it will be like this: a2, q4, then here the remaining states. Okay, so that's what is the instantaneous description. And after that we have the transition table. In the transition table we have the present states and the tape symbols, and this is divided into two parts: the states here and the tape symbols. And the states are like, if there is an arrow it's a starting state, if there is a circle it's the final state. And q1 on b, where it goes? It goes on, it makes the symbol as 1, and it moves to the left and makes the goes to the state q2. So that's what the representation is for each of the tape symbol. Okay, and the transition diagram, we all know we are moving from one state to another state on, like for example, if you want to move from q0 to q1, if we get the input 0, then only we can move, and it is on x and we will move to the right. Okay, so this is the representation of the transition diagram, and this is what you have to do in the first question. After that, moving on to the second question, what we have is explain the variants of Turing machine. Okay, coming to the variants of Turing machine, there are mainly two types of Turing machine. The first one is multi-tape, and the second is the undecidable. So in the multi-tape Turing machine, we'll have one Turing machine here, which will be connected to 3 strings here, and it will be pointing to any of these letters. Okay, so if it is pointing to a, then a is the head here. If it is pointing to y, y is the head here, and if it's pointing to 0, 0 is the head here. So converting the multi-tape into a single tape, we have to make a single diagram here, and we'll have the letters a, b, c, then x, y, z, and 0, 1, 0, 1, and that will be separated by a hash here. And whichever place it's pointing to, like t is pointing to a in the first one, and y in the second one, and 0 in the third one. So at the top of that we will have a dot here. Okay, dot represents which place the t is pointing to. Okay, so and the key points which you have to explain are: what is a Turing machine, and what is the header? Header means it's pointing to here. Okay, so that is the header wherever it points to. And control state means from which state it is going to which state, that is the control state. This first state, second state, and so on. And the multiple marks means at the same time multiple marks are stored, and how the moves happen because of the inputs and the transitions will move to the first state, second state, and so on. And the single state representation means this whole thing will be converted to a single state. So this all key points should be included in this to convert the multi-tape Turing machine into single tape Turing machine. Also there is an theorem, the same thing you have to do in the theorem also. For every multi-tape Turing machine there is an equal and single tape Turing machine. So if they ask this theorem also, you have to do the same thing. The second type of Turing machine is the non-deterministic Turing machine, and firstly you have to make this diagram, like what is the meaning of non-deterministic. From one state it goes to two different states on the same input symbol. Okay, so after that you have to write it's defined by 7 tuples, and define the 7 tuples, and after that write this expression. Like for the first transition q on x, where it goes to q1 y runs from y1 till yn. Okay, so it can have different outputs on the same input x. Okay, if I write the example, the transition of q on x is q1 y1 l, q2 y2 r, and q3 y3 l. So it can have different outputs. Okay, so that was about the two types of Turing machines. And after that we have the linear bounded automata. Okay, so here this is the sequence. The first one is FSM. Okay, powerful than FSM is the PDA. After that it comes linear bounded automata, and last one is Turing machine. Okay, so here we will be learning about linear bounded automata. Here what we have is the same thing as the Turing machine, just that it will have the size input constraint. There will be no backspaces. Okay, means blank spaces. So here dollar is representing the start and the end of this string, and in between we'll have the string. All the rules of the Turing machine apply here. Okay, and that is the linear bounded automata. And there will be two types of tapes. The first is the moving tape, and second is the working tape. The moving tape does not move to the left, only it stays or move to the right. Okay, and read write head does the reading and writing operation. Okay, And the key points are as follows. It's defined by 7 tuples. It has 2 tapes, the working tape and the moving tape, and it is more powerful than push down automata. It can accept the strings a power n, b power n and c power n. This is the drawback of PDA. PDA cannot accept the string a power n, b power n and c power n. Okay, and it is less powerful than the Turing machine. It's non-deterministic, and deterministic are there in the 3, but in LBA it's not the case. LBA is just LBA. Okay, and it is designed for context sensitive language. Okay, so if you write this, I hope it should be sufficient for the linear bounded automata. So that's all for the module 4 of automata, and thank you for watching. I'll see you in the next one.